Hello everyone, so this is the third tutorial at looking into robotics using the language Go. So in the first two videos we saw how to use OpenCV and how to detect faces through a Raspberry Pi using the PiCam. Now, the idea is to make a robot, so we need the computer to be able to use actuators. That would be servo motors, stepper motors, wheels, DC motors, maybe have a few sensors. Should it be ultrasonic sensors or even LiDAR? I don't know. So for the proof of concept, I want in this video and maybe in the next one, because otherwise it might be a bit too long, show you how you can connect through USB to an Arduino with the Pi and can program everything in Go. So the framework I'm going to use is Gobot. So Gobot, I've talked about it a little bit. So it is for robotics and IoT. The main idea is that this is a framework, but also a way of organizing your code. So Gobot just received a text. Never mind. So Gobot has, as I said, many platforms, and what you want to do is, in order to have the Raspberry Pi talk to the Arduino through serial, so through the USB, is to use a framework which is called Fiat Meta. It's a protocol that is based on the MIDI interface. So it's not exactly MIDI, of course, but it's apparently the same idea. That's the way it's programmed. And the idea is that you can therefore just exchange information quite rapidly enough so it makes sense, basically. So the first thing you want to do is plug in your Raspberry Pi and the Arduino. In my case, I got an Arduino Arduino Duo, because I wanted, it's one of the most expensive, but also one of the fastest board Arduino selling, but it uses a different chip. So basically it's not compatible with everything Arduino is doing. You can see in the store, if I look at the price, well, it's not that expensive. It was a bit more expensive before. But if you got any Arduino, should be the, if I look in there, it should work with any like normal board. So the Duo, it will work with the Nano, it will work with the, well, any board, basically. So the first thing you want to do is install Fiat Meta on the Arduino. You could do this through the Raspberry Pi, but I was actually much more successful doing it through on the Windows machine. So you just plug the Arduino board on the Windows machine, then you go into include. So it doesn't show, but you click on Sketch, then into include. Can I show? Does it show? No, it doesn't. Okay, give me a second. If I do, no. Okay, give me a minute. Capture. Okay, let's do that. So it's going to be a little bit psychedelic for a minute. Okay, so what I meant is that you click on Sketch, include libraries, and then manage libraries. A new window is going to open, and in there, you type firmata, and you want to install this. So you select the latest version, you click install. So I did that already. And what this allows you to do is, if I go back here, is then open in the examples. I think I still have to, okay. I still have to do it through this. I think it was in the examples, you needed to click on firmata and use the, I use which one? I use the plus, so standard Fiat Meta plus, or you just use standard Fiat Meta. So you open this example, then in the board, you select your board. Mine's not plugged in my PC, so it doesn't recognize it automatically. But you select the board, and then you just flash the memory. And then Fiat Meta is going to be installed on your machine. So once that is done, you can simply plug the Arduino into your Raspberry Pi, and if you then ls dev, the Arduino is which one is it? So these are all everything that's plugged into the CPU. Basically, you got many stuff like standard in, standard out, but also this is the PiCam video 0, and the this is TTYACM0. This is my the Arduino for me. So we'll be able to connect to that. So what we want to do is then install Gobot. So it's quite simple. It's a one-line thing to do. So you just type this into the terminal, and then you can start programming. And the way it works is that you import the different packages, including Fiat Meta. You make a new adapter, which will be the Fiat Meta adapter. So that would be an interface, and you just specify the port. Then you can start different drivers. So these could be, in this case, LED, but it can also be a servo motor, stepper motor, whatever that you want. And then you do some work. So you declare this variable, which will be a function, with the work that it has to do. So you do the work in there. And then with this is the work the robot needs to do. So then you declare new robot, and you pass in the arguments, which are the connections and the devices. So basically what's in there, and then the work that needs to be done. And when you start this, it's basically going to run this function. But what's cool with Gobot is that if you go into guide master, it shows you that what you can do is actually declare a new master, which will then which will control different robots. So basically, the way I see it is that it's a way of doing parallel tasks. So it's just going to start everything in its own process. I'm simplifying because I don't know how it works underneath, but it's going to start everything in a separate process. So you can have a script that only does the facial recognition. You can have a script that only behaves only takes care of the motors. You can have a script that only takes care of a website and all that. But thanks to Go and the use of channels, all these processes can communicate together. So what you can do is have the webcam that sends through a channel to the robots, to the process that's responsible for controlling the motors. The camera can just send some values for the motors to move for. So basically saying that this is how far the face is from the center of the image, and the motor is going to move until you meet some kind of threshold. So this is what I want to do in this, and maybe in the next video as well, because looking at the time, it's already been 10 minutes. So what we're going to do now is quite rapidly just put the code together, make the few scripts work, and then in the next video, I'm going to show the setup with the actuators themselves and finish this tutorial. So we go into Atom. We're going to make a new folder. So that will be tutorial 3. Oops. Rename. And in this one, I'm going to make a new file, which will be main.go. And in there, we're going to import package main. No, just package main, then import. What do we want to import? We're going to import gobot.io/x/gobot. And the Fiat Meta one. So it will be gobot.io/x/gobot/plat form/firmata, and that's maybe because I want to print some stuff. So import format. Okay, now we make the main function. So the main function is just going to take care in starting the master, then calling the different function which create the different robots, add all the robots to the master, and then start the process. So we create a new master, which is Gobot.new master. So you can see this library is quite homogeneous and coherent in its way, in the way it works. So we do this, then we simply call we're going to make some new functions. So we're going to have one which is specifying the Arduino, which will be Arduino. No, I'm not going to put it here. I'm going to do master add robot and then Arduino, and this will be a function in a different file which is only responsible for the Arduino stuff. And then we can do a master add robot, and this robot could be camera with a capital C to export it, camera, and then master start. So that's basically it. Okay, I'm not going to bother with the channels right now. We can do that later on. But now this is basically going to start these two processes and keep them in this master thing. So we can save this. Then we can make a new file, which will be Arduino Script, Go, Arduino Robot. Keep the same syntax in there. So package, main, import, and it's going to be the similar import. So I'm just going to copy and paste this. And I just realized we're not using this here, and we can put fmt print line starting master. So we get a queue. Okay. Here, so we keep the same, and in there we create a function which was named Arduino, and it is this function is going to return the robot. Okay, so it's something like GoCV robot, I think. I'm not sure. Let me check. It's at the bottom of this. No, it's not GoCV, it's Gobot, and then robot. So this is going to be returned. So we can do return robot for the end. Okay. And now in there we need to create the new adapter, which will be firmata adapter. So let's quit FA, which will be firmata.new adapter. And as I said, the URL will be tty_mcm0. Sometimes this can be 1. So yeah, just know that. And what can we do? We can let's declare the LED as in the example. So GPIO and new LED driver. We give it FA, and then we give it the pin, which is 1313, if I'm not mistaken, is the built-in LED. So because we're using GPIO, we need to import it here. So it's Gobot x Gobot drivers GPIO. Great. So in there, we need to now start write what the work is going to be. So the work is a function, and function with no arguments, but we need the parentheses. And what we can do is use the Gobot looping function, which is going to loop every, let's say, 500 milliseconds. Time dot millisecond. That means I need to import time. Here we are. Millisecond, and in this millisecond, we're going to use a function which will basically just toggle the state of the LED. So every half a second, basically, the LED will blink. Great. So let's tab this, remove this. Okay, so that's basically the work done. Now we need to create the robot. So the robot is Gobot new robot. We give it a name. So this is going to be Blinky. Then we give it the connections, as in the list of connections. So Gobot connection, and the connection is going to be FA. Then we give it a list of Gobot devices. So this would be the drivers, and the list in question just includes LED. And lastly, we give it the work. Then we return robots, and this, if we save that, is going to be added to the master. So that's great. Then we just need a webcam, the camera. So what I'm going to do is just create a new file, which will be camera robot, and I'm just going to copy and paste and a bit modify the text from the script from the first tutorial, which basically just streams the data. Oops, it's not .py, it's .go. Streams the data on the HTTP server. So what do we want? So we're keeping this, so we're keeping GoCV. If you have any questions on all that, I'm not going to go through it. You need to look at the first tutorial. What we want to do is change the name of the main function. So we want it to be called camera. Okay. We want this camera to return gobot.robot. Okay, this means we need to import Gobot. So I'm just going to copy this from there. We need to return that to import this. Let's put it underneath. So we need to return this. You know what? Actually, this is going to be its own function. So function camera. This is going to return that. And it's going to be stream camera. Okay. So here we just repeat what we did in the other one. So if I just close this and that, because it's confusing me, I'm just going to copy and paste all that in there. Okay, instead of doing this, we're just going to call this in. Let's see if it's a good idea. If we do go like that, will it work? Camera, we don't have a device, we don't have this, we just have that. Just checking. This looks fine. I don't think we need this, actually. So, and we return robot. This is going to call this. Okay, so I think we are done. So what I did is I made this camera function, which is just going to create a work, which includes the function stream camera. Then we created a new robot, which only has a work. It doesn't have a device or a connection. Everything, connection, device, and all this is controlled by GoCV, because you could use OpenCV through Gobot, but it's not as developed as GoCV. So I would rather use GoCV for that. And that's pretty much it. So now if we go into our terminal, we can change directory, so tutorial 3. Okay, so if we do go run everything that ends with go, what happens? Okay, first typo. So now the Arduino script, line 19, I forgot or added a comma. Let's make sure, let's check where the issue is. First we can remove this space. expected comma or Really? Oh, it's actually at the bottom here to work. Okay, what about now? Import FTP, okay, well that. So I imported it but never used it. So we can remove, I just removed this. Okay. Then we save. And now, waiting. Okay, so what can we read here? We read that we have a connection using firmata on the device. We created the LED. Both robots were initiated. Then Blinky was started, and now we are streaming. So what we can do right now is look if we are indeed streaming. So if I open this, so we've got a live feed. Now the question is, if I remove all the wires that are connected to my Raspberry Pi, I can show, just need to move that. Okay, so the LED here, is it focusing? It's not focusing. Well, you can see that you've got the orange LED that's flashing every half a second. You've got the other one that is flashing a bit more rapidly. So if I tilt it like this way, okay. So the one on the, the quality is not. The one on the right-hand side, which is flashing, is the communication LED. So basically every time this flashes, it's because you have a communication through the USB. The other one that's flashing orange a bit slower is the one we are wanting to blink. So in our case, it works. Maybe with this camera I can see it better. Okay, well, it's not emitting any infrared, so we don't see anything. Anyway, so I'm going to put this back here. So what we see, I'm just going to stop him because he's annoying me. So what we see is that it did work at the end. So we have both processes working at the same time. So you can see where the robot capabilities can come in handy, because basically you could have a file per thing you want to do, and as long as the CPU is not overwhelmed, you should be fine. I mean, if I go back here and we look at the CPU, it's barely 10%. Okay, if I put the stream back, so it's 15%. I got streaming and communicating with the Arduino. I'm not sure about this. So some of the speeds. For instance, I have this little, where is it? I had a little OLED screen. I can't find it. I've got a small OLED screen that works through the SDL and SDA communication ports on the Arduino. This is going to be very slow. I2C buses through Fiat Meta there are going to be bottlenecks. That's what you need to keep in mind. Nevertheless, that's it. So I'm going to stop here. In the next video, I'm going to plug back in all the actuators, the server, the motors. I actually have the little here. So it's the little infrared camera. So you can actually see the infrared. So I've got a servo motor at the back. I've got a little stepper motor underneath with some circuitry. It's a bit like some sort of rat's nest. But the idea is to have it move. So this is going to be for the next video. If you have any comments, suggestions, any questions, or you know how to use YouTube, if you want to like and subscribe. You still know how to use YouTube, and I guess I'll see you next time. Cheerio.